Hello everybody and welcome back to the channel. In this video we're going to talk about how to solve radical equations, and specifically we're going to look at square roots and cube roots. So here we go. What is a radical equation? Well, it's just an equation that contains a radical expression with a variable in the radicand, so something like that. We're going to use inverse operations to isolate this radical. So if we have the square root of x and then plus 5, we want to subtract 5 so that we get the radical by itself. We want to isolate it. Once we have the radical by itself, now we can raise both sides of the equation to the appropriate power. What I mean by that is what we have down here in yellow. So if I have the square root and I'm trying to undo the square root, well, the inverse of that would be squaring both sides of the equation. And what I mean by squaring, we're going to raise it to a power of 2. If we have a cube root, we're going to raise to a power of 3. And whatever we do to one side, we have to do to the other side because it's an equation and we have to keep it balanced. If we have the fourth root, we're going to raise both sides to a power of 4. Fifth root, both sides to a power of 5, and I think you understand where I'm going with this, okay? So let's look at some examples. We have the square root of x plus 4 equals 9. So we want to subtract 4 so that we can have the square root of x equals 5. Now that radical is by itself. It's a square root, so we can raise both sides of this equation to a power of 2. The square root of x squared will give us just x, and 5 squared is 25. So our answer there is x equals 25. For the next one, let's subtract 10. And now we have negative square root of x equals negative 15. We don't want a negative there, so let's go ahead and divide both sides by negative 1. That's just a sign changer. It's going to get rid of that negative for us. So we have the square root of x equals positive 15. Now since that radical is by itself, let's go ahead and raise both sides to a power of 2. So this gives me x equals, and 15 squared is 225. All right, now let's look at some where we have a couple extra steps that we might have to do. So example 2a says 3 times the square root of x plus 5 minus 1 equals 11. So a couple things we need to do here. First, let's add 1. So we have 3 times the square root of x plus 5 is now equal to 12. Now let's divide both sides by 3. So now that 3 is going to go away. So we have the square root of x plus 5 is equal to 4. Now the radical is alone by itself. It's not just x in the radicand, so we're going to have another step after we square both sides. So now we have x plus 5 equals 16, and now we need to subtract this 5 to get our final answer of x equals 11. Okay. Now let's look at b. Notice here we have a radical on both sides. That's okay. We're just going to raise both sides to a power of 2. All right. So now this just cancels the radical on both sides, and we're left with an equation that has variables on both sides. So let's go about solving this. Let's subtract x to get 3x minus 3 equals 9. Now we can add 3 to combine our constants. So we get 3x equals 12. And lastly, we want to isolate x by dividing both sides by 3. So we get a final answer of x equals 4. All right, last couple examples we'll look at involve cube roots. So now we're not going to raise both sides of the equation to a power of 2, but a power of 3. So since our cube root is already isolated, there's nothing else being added or multiplied or anything like that, we can go ahead and raise to a power of 3. So this is going to give us 2x minus 5 is equal to 3 cubed is 27. Now we can go ahead and add 5 to both sides. So we get 2x is equal to 32. And lastly, just divide by 2 to get a final answer of x equals 16. Last example. Once again, the cube root is already isolated. So let's go ahead and raise both sides to that power of 3. We get a 3x plus 7 on the left and a 1,000 on the right. Now let's subtract 7. We get 3x is equal to 993. And lastly, we divide by 3 to get a final answer of x equals 331. And that is how you solve radical equations, specifically square root and cube root equations.